Today we will talk about kinematics in one dimension. The simplest possible motion is motion along a straight line at a constant unvarying speed. Constant unvarying speed means velocity does not change, velocity constant. So shortly we say v equal to constant. V constant. This is the simplest possible motion. We call this uniform motion. This is important keyword. We call it uniform motion. This is a keyword because velocity is a combination of speed and direction. Uniform motion is a motion with constant velocity. So uniform means motion with constant velocity. We can explain it in terms of diagrams, as you remember from my previous lesson. If you have a motion with constant velocity, it means the size of the arrows will be same. Yes. For example, this is a frame, first frame, second frame. The size of the arrow should be same because we are talking about motion with constant velocity, or we are talking about uniform motion. So basically, if you want to draw this kind of diagram, then size of this arrow should be equal to each other. Then this will be diagram for uniform motion. So this is one of the ways to explain uniform motion in terms of diagram, motion diagram. Basically, this blue solid lines explains velocity, describes velocity. Let's use small v. You can also explain in terms of graphs. So let's draw position graph. Position versus time. Position versus time. So x. Let's say initial position was 0. Yes, for example. After some position becomes, for example, 1. After 1 more second it becomes 2. After 1 more second it becomes 3, etc. So this is how you need to draw the graphs. So basically you will get straight line. This kind of straight line. So this explains motion with constant velocity, because we know that with constant velocity, object, vehicle, it will cover same distance for same interval time. That's why you should expect straight line. So now let's study this graph, for example. What we can see, initially position was 0, then position increases, positively increasing. It means velocity for this graph is positive. What does mean positive? Positive means this object is moving to the right side. Usually we say that if object car moves to the right side, we say positive velocity. If car or object something moves to the left side, we say it's moving in the wrong direction. So we should expect velocity negative number, negative value. How we can draw position time graph for the object which is moving to the left, for example? It's simple. Similar graph, position, time, and so this graph, be careful, it has a negative side. So upward positive, downward negative. So if object moves to the left side, it means you should draw this kind of straight line. So this graph corresponds to the motion with negative magnitude. Negative means it's just sign, and it means this car is moving to the left. So let's summarize this part quickly. Position time graph. If you have a straight line, it means we are talking about uniform motion with constant velocity. As you know, velocity is a vector, direction is very important. If you have this kind of graph, then it means car is moving to the right side. If your graph goes downward, like in this one, it means your object is moving to the left direction, in the wrong direction. And this is just one example of the graphs. You can also draw different graphs. For example, velocity time graph. VT, shortly we say. Time, velocity. Of course, time, it can be in hours, in seconds. Velocity, it can be in kilometer per hour, meter per second. So here, let's say seconds, meter, and the seconds. So now let's come to the VT graph, velocity versus time graph. Again, we need to draw for uniform motion. Uniform motion means velocity remains same. It means you should have horizontal straight line, because this value, let's say for example 5 should not change, because this is a uniform motion. And the positive 5, this is a positive number, so it means this car is moving to the right. What if object is moving to the left, for example? Then velocity should be negative. So this is, for example, negative number. Yes, here we have a 0, here we have 0. Below the 0 we have a negative number, for example, minus 2. Negative 2, it means this car is moving with constant velocity to the left. Negative just shows you direction. So let's solve one example. Pay attention to this example. So we have figure 2.2, I will show you later, is a position versus time graph. Position time graph given for a car. So what we need to do, draw the car's velocity versus time graph, VT graph we should draw, and describe the motion. So first let's draw velocity versus time graph. So let's go to figure 2.2. So this is a figure 2.2. This is figure 2.2. Now let's study this graph. What we have? We have a velocity, we have a position and a time graph. We have a position, time. Then initially at the beginning of this motion, for this motion, you see position equal to 0. Position equal to 0. So it starts with 0 position. After 1 second, its position becomes negative number. Likely this is a minus 2. Likely it's a negative 2. Yes? So after 1 second, this car's position becomes minus 2. What does it mean minus 2? It means this car is moving to the left side. Because as you know, let me draw it here. Position is 0 here. Then 1, 2, positive number. It's positive to the right side. Yes, x. Then it will be negative to the left side. Minus 1, minus 2. So initially car was here, 0 position. After 1 second, it is here. So it's moving to the left side at the beginning. Then after 2 seconds, this car's position becomes negative 4. It means this car is still moving to the left. So initial two seconds, car was moving to the left. So it's a negative velocity because it's moving to the left. So and we know it's a uniform motion because this line, this graph is straight line. And you know that for uniform motion we have a very simple equation. You know it from the school. X equal to vt. Yes, distance equal to velocity times time. Distance for this part for initial 2 seconds equal to 4 meters. Yes, it was 0, then becomes 4 in 2 seconds. Velocity times in 2 seconds, velocity equal to 2 meter per second. But be careful. You should not forget to put negative sign. Negative just shows you the direction. It was moving to the left. So initial 2 seconds, velocity equal to -2. Now, after 2 seconds, what happens? Position remains constant. -2, -4, -4. After 2 seconds, or at time 4 seconds, it's still position -4. What does it mean? It means this car is not moving during these 2 seconds, during next 2 seconds, because position remains constant. Position is not changing. It means this car is staying at one point. It's not moving. So velocity basically 0. So here velocity equal to 0 between 2 seconds and 4 seconds. Then after 4 seconds, what happens? At 5 seconds, position becomes again 0. So at 4 seconds, position was -4. Approximately at 5 seconds, position becomes 0. What does it mean? 0 is at the right side of the -4 in terms of position. So it means car started moving to the right side. It means we should expect a positive number for velocity because it's moving to the right side. It's moving to the right at 6 seconds. Position becomes, I think it corresponds to the 6 meters. Yes, approximately. So let's consider time interval between 4 seconds and 6 seconds. Here and here. Time is 2 seconds. What is a change in position? Initial position was -4, then becomes 6. So how many meters it moved to the right? So -4 is here. Here we have a 0, for example, and here we have a 6 meters. Car moved for 10 meters, yes? From -4 to 0, we have 4 meters, and then from 0 to 6, again, we have a 6 meters. So total 10 meters. So again, we need to use our simple equation, x equal to vt. This x is distance here. It moved for 10 meters in 2 seconds. So velocity becomes 5. Of course, this is a positive number because of direction. So let me draw it here quickly. We had a position time graph. I will do it roughly. So initially, a position was going to the negative number. So here we have 2 seconds, 4 and 6. Yes, this one, if I'm not mistaken, -4. So let me draw parallel to this one, velocity time graph. Yes, this was the first question. So we know that here, during the initial 2 seconds, velocity was negative and it was equal to 2. Yes, so we can draw this kind of, and we know that this is a uniform motion, so velocity should not change. It should be constant. So here, initial 2 seconds, velocity was equal to -2. From 2 seconds to 4 seconds, position was constant. We explained it already. It means velocity was equal to 0. It was at rest. It was not moving between 2 and 4 seconds. So basically velocity is 0 here. This is a 0. So here we have a 4 seconds. Then between 4 and the 6 seconds, it moved it to the right direction, and the distance that it covered was 10. Yes, 6 minus 4, it becomes 10. And we divided 10 by 2 seconds, and we got velocity positive number and the 5. Positive because of direction, yes, it was moving to the right. So between 4 and 6 seconds, velocity was equal to 5, positive 5. So this is how you can quickly draw or convert position time graph to the velocity time graph. Now we know that distance equal to velocity times time. We can use this equation when we have a uniform motion or motion with constant velocity. So shortly we say x equal to v times time. V times time. This is one of the main equations that we use for this kind of motion. So this equation sometimes can be given in terms of position. So for example, x2 equal to x1 plus vt. Sometimes you can see this kind of equations. So this equation is totally same equation, which we highlighted here. The difference is the blue one, the equation that was highlighted by blue one, is in terms of distance. So this x is distance, be careful. But here x2 and x1, it's not distance, this is position. So first of all, you should choose which method you will be using: distance method or position method. Of course, distance is equal to what? Distance equal to final position minus initial position. So you can write your equation in terms of distance or in terms of position. It's totally up to us. If you have a graph method, it's better to use position method. Position method in previous example, for example, x. This was a graph, yes. 2 seconds. Initial position was 0. Final position was -2. So here we can say that this is initial position, which is x1, 0. This is the final position, x2 equal to -2. So you can say it moved for 2 meters to the left. It will be distance. You are talking about distance. Or you can solve this problem in terms of position. So in terms of position, x2 equal to x1 plus vt, yes. Final position -2, initial position 0, velocity unknown in 2 seconds. So -2 equal to 2v, so v equal to -1, for example. Yes. So you see, you get negative number. So there is no way to make mistakes here if you decide to solve the problem with this method, position method. So let's summarize it. You can say x equal to vt, then it means you are talking about distance, or you can write the same equation in terms of position. So x final position equal to initial position plus vt. X is position here, final position. This will be initial position. For example, let's solve this problem. what we have? Bob leaves home in Chicago at 9 a.m. morning and drives east at 60 miles per hour. Susan, 400 miles at the east in Pittsburgh, leaves at the same time and travels west at 40 miles per hour. Where will they meet for lunch? So let's try to draw the diagram, yes, because it will make our solution easy. So first, this point is Chicago. 400 miles to the east in Pittsburgh. So let's say this is Pittsburgh. So Bob leaves home in Chicago at 9 a.m., drives east at, so velocity of the Bob equal to 60 miles per hour. So let's call it just V1. Yes, and equal to 60. And 400 miles to the east. It means this distance equal to 400 miles. This is a mile per hour. So first of all, we need to choose our origin for the position. Yes. So to make it simple, let's say Chicago is the origin. Chicago is origin of the position. So position will be positive to the right side. Yes, x. So this will be x0. Let's say this is a x1. So it's obvious that x0 equal to 0. This is initial position. x1 is, this is the position for Pittsburgh, and equal to 400, positive 400, because it's at the right side. And Susan lives at the same time and travels west at 40 miles per hour. So we have a V2, direction is to the left, and this V2 equal to 40 miles per hour. Where will they meet for lunch? So it's obvious that, okay, first of all, let's summarize it. We draw diagram to make it simple, and we choose our origin for x position as Chicago. So Chicago located at 0 position. And Pittsburgh's position is positive 400 miles. And the V1 is directed to the right, 60. V2 is directed to the left, 40. And where will they meet? So basically, at what position they will meet? This is the question, yes? At what position? We don't know at what position they will meet, but it's obvious that this position is between 0 and 400. So let's say this is a position where these two beautiful, very good people will meet for lunch. Yes? So let's call it x2, and this x2 is unknown. Of course, we need to find this position x2. We know that Susan lives at the same time. It means time travel for Bob and Susan will be same, totally same, because they will spend same time to reach the meeting point. So now we can write two equations. First one is for Bob. Second one is for Susan. For Susan. And we know that they are moving with constant speeds, constant velocity. So this is, we are talking about uniform motion. It means we can use this equation for both persons, yes? But here, be careful, x2 is the final position, x1 is the initial position. So let's write this equation for the Bob. Final position, unknown. Initial position, 0 for Bob, yes? Velocity, 60, positive 60, because of the direction it's moving to the right. Time, unknown. So we have this kind of equation, x2 equal to 60 times time. As you see, we have two unknowns in this equation. So this equation is not enough to solve this problem. Second equation will come from Susan's motion. So again, let's write the same equation for Susan. Final position, same x2. Initial position is 400 miles. Velocity will be negative because Susan is moving to the left. That's why we will use negative sign, negative number. Time unknown. So x2 equal to 400 minus 40t. This is the second equation. And we have two unknowns and we have two equations. It means we can solve this problem. So what we can do, let's number it. This is the first equation, this is the second equation, to keep it in mind. So now we can substitute, we can bring x2 from the first equation and put it into the second equation. Then let's see what we will have. So we will replace x2 with 60t, 400 minus 40t. Let me take 40t to the right, to the left side, so it will be plus 40t equal to 400. 100t equal to 400, so time equal to 4 hours. So they will meet after 4 hours. After 4 hours. But question was, where will they meet? So question was not time, question was position, yes? So we need to find x2. We can come back to any of these two equations, previous two equations. Let me use equation number 1. We know that x2 equal to 60 times time. Time is given, which is 4. So x2 equal to 240 miles. Yes. So this is a final answer. They will meet at 240 miles. So this is a position. This is a position and this will be our final answer. Now let's stop to think. Which position versus time graph represents the motion shown in the motion diagram? So we have a diagram. This is the diagram. And we should represent it in terms of position time graph. So first of all, before going to the options, let's study this diagram. What we have a position, and you see origin is here, 0. This is the origin, yes? So to the right it's positive, to the left is negative. And this green arrow is velocity, as you see here, velocity. And this arrow is directed to the left. So basically it's moving to the left direction. What does it mean? It means velocity is negative. Yes, velocity is negative, or we can say position is decreasing. Position is decreasing. For example, it was here. Let's say position was 10 meters, for example. Then it becomes, I don't know, 6 meters. Then it becomes 3. Then it becomes 0. Then it becomes -3, etc. So it's moving to the left direction. Position is decreasing. Position is decreasing. So now let's come back to the options. So first option, you see position is increasing. So this is wrong. Here, B, position is decreasing. Yes, but initial position equal to 0. Initial position equal to 0. But we know that from the diagram, initial position is not equal to 0. It's more than 0. It's bigger than 0. So B also wrong. Let's come to the C. Position is not changing. Yes. Let's say it's 5 meters, and it's always 5 meters. It means this this object or car is not moving, it's at rest. Now let's come to the D. Position is decreasing, yes, it means it's moving to the left. Initial position is more than 0, which is also correct. So I think answer is D. Answer is D. So answer for this question is D, because position is decreasing and initial position is not equal to 0, it's more than 0.